Good morning, all of you. So, how are you all? Good. So, let us start with our session. Previously, we have discussed about what the electric charges are, and also we have discussed about the electric current. What is the direction of electric current? What is the unit of electric current? And how the electric current is made of, or how it is being generated or created. So, now we will be discussing about the second part of this particular chapter, and we will be including particular topics that are potential difference and the resistance, as well as we will be completing the Ohm's law in this particular section. Okay, so moving ahead, what is electric circuit? So closed and continuous path of flow of current or closed and continuous path of flow of electron is called as electric circuit. What does it mean? It means if there is a closed path and also it is a continuous path, the path is not breaking, in which the electrons flow or in which the electric current flows, then that particular path is called as electric circuit. Now the electric circuit is composed of some of its components. What are those components? So cell. The cell has two terminals, the positive and the negative. The longer terminal is the positive terminal and the shorter terminal is the negative terminal. The battery are composed of cells. Two or more than two cells constitute to form a battery. Resistor. What does resistor means? Resistor is basically a material which has the tendency to resist the flow of the electron. Okay, so in general we can say any of the material or all of the material has some of the tendency to resist the flow of the electron. So yes, it is resistor. Resistor is represented by this particular symbol. Variable resistor or rheostat. Variable resistor or rheostat is depicted by this particular symbol. And what is variable resistor means? It means we can vary the resistance of this particular resistor. Now, what does this resistance means? The ability of a resistor to resist the flow of electron is called as its resistance. Am I clear? A resistor is a material which has the ability to resist the flow of electron, and the ability of that material to resist the flow of electron is called as its resistance. So this is particular variable resistor. Moving ahead, and here we go. The plug key. It is the open plug key, and the second one is the closed plug key. The bulb is represented by this symbol. Crossing over of wire or cable is represented by this particular symbol, and if there is a joint in the wires, then this is particularly represented by this symbol. Moving ahead, now the ammeter is represented by this particular symbol, the voltmeter is represented by this particular symbol. Now what does this ammeter and voltmeter means? So ammeter is a device which is used to measure the current. Ammeter is a device which is used to measure the current, the amount of current. And what is voltmeter? Voltmeter is a device which is used to measure the potential difference across 2 points. Now, what is potential difference? We will be discussing it. Okay, what is potential difference? We will be discussing it. Now talking about the electric circuit, how we will be drawing a particular electric circuit. So come, let us practice how we can draw the electric circuit. So here we go. So this one is the positive terminal, this one is the negative terminal. This is the battery, this is the resistor, and here we are putting an ammeter. And here we are fixing a voltmeter. Okay, and here we are also fixing a plug key, okay, which is closed. Now if there is a battery, a current will be flowing in this particular section, and this particular section in which the current will be flowing will be called as electric circuit. Am I clear or not? This particular closed and continuous path or closed and continuous curve in which the current is flowing or the electrons are flowing is called as the electric circuit. And here the electric circuit is composed of a battery, a plug key, an ammeter, a voltmeter, and a resistor. So let us say the resistance of resistor is R. R is the resistance of resistor. Resistance of resistor. Okay. Talking about the ammeter, we have to note down the polarity of the ammeter. The positive terminal of the ammeter will be connected to the positive terminal of the battery. The negative terminal of the ammeter will be connected to the negative terminal of the battery. Same goes on for the voltmeter also. The positive terminal of the voltmeter will be connected to the positive terminal of the battery. The negative terminal of the voltmeter will be connected to the negative terminal of the battery. Now, why is it so? Why we are doing like this? To maintain the flow of current. To maintain the flow of current, we are just fixing our ammeter and voltmeter in this particular alignment. Okay, so this is a particular electric circuit diagram. How does it looks like? So now moving ahead, ammeter was used for measuring the amount of current, voltmeter was used for measuring the potential difference across the 2 points. Now what does this potential difference means? So let us understand about potential difference. What is actually a potential difference? Or what is a potential? If someone says define potential, so what is potential? So potential is a difference. So potential is a reference dependent. First of all, potential is not a fixed term, it is a reference dependent term. So potential cannot be defined, but yes, potential difference can be defined. Now what does this potential difference means? The potential difference can be defined as the amount of work done. See, the potential difference can be defined as the amount of work done to move a particular charge from one point to the other point. What I am saying, suppose I am having a particular charge, say Q, which has to be moved from this particular point A to this particular point B. So some amount of work has to be done. Why work has to be done, sir? Because in our circuit there is a resistance, and if there is a resistance, then we have to perform a work, and the work will be performed by battery in this particular case. Okay, now if a battery is performing a work to move a charge from one particular point to this particular point, so we can define the potential difference across the 2 points is the amount of work done, on moving a charge from one point to the other point, per unit the charge moved, or the moving charge, Am I clear or not? What is potential difference? Potential difference is defined as the amount of work done in moving a charge from one point to the other point per unit that moving charge. Now what is it, sir? We are not getting. If you are not getting, so let us suppose I am saying that the charge is plus 1 coulomb. The charge is plus 1 coulomb. It means it is a unit charge. And what is its polarity? Positive. So it is unit positive charge. And we are testing something. We just want to know the amount of work done. So it is basically called as unit positive test charge. Now, if I have said that suppose the charge is plus 1 coulomb. So now the potential difference will be defined as, suppose the potential difference is defined as delta V. So delta V is equal to amount of work done per unit moving charge. And what was the moving charge? The moving charge was plus 1 coulomb. So we don't need to write down 1 in the denominator side. So yes, we can say that delta V will be equal to work done. Am I clear or not? So how we can define the potential difference? We can define the potential difference as the amount of work done on a unit positive test charge. The amount of work done on a unit positive test charge to move it from one particular point to the other particular point. So the amount of work done to move the unit positive test charge from one point to the other point is called as the potential difference between these 2 points. Am I clear or not? If the charge is moved, unit positive test charge is moved from one point to the other point, then the work has to be done. And this work which is to be done to move it from one point to the other point will be equal to the potential difference between the same 2 points. So yes, potential difference is equal to amount of work done. Now, what I am saying, if I am saying that suppose delta V, we are moving it from A to B. So delta V is defined as final potential minus initial potential is equal to work done. Okay, final potential minus initial potential is equal to work done. So we can say that V final minus V initial is equal to work done. So moving ahead, so delta V was W by Q moving, the charge which was moved, and we have defined that V final minus V initial is equal to W if Q moving was plus 1 coulomb. So now if I'm saying that the potential of infinity is 0, if I am defining that the potential of infinity is 0, I'm defining it for my reference. I'm defining that the potential at infinity is 0. So if we want to define a potential of particular point, suppose I want to define a potential of C, and here the charge is again plus 1 coulomb. So the potential difference between these 2 points, that is C and infinity, will be equal to the amount of work done to move a charge from here to here. So delta V is equal to W, and delta V final minus V initial, it means VC minus V infinity is equal to work done. In this particular case, if I am talking about that, in this particular case, the VC minus V infinity, because the final point is C and the initial point was infinity, the unit positive test charge was to move from infinity to the C point. So VC, V final minus V infinity, that is V initial, is equal to work done. Okay, now VC minus V infinity is 0 is equal to work done. So we can say that VC is equal to work done. So we can also define the potential now on fixing the potential of infinity. If we are fixing the potential of infinity to be 0, we can define the potential of any of the point. Now how we can define? We can define the potential of a particular point is defined as the amount of work done on moving a unit positive test charge from infinity to this particular point. What was potential difference? The potential difference was amount of work done to move a unit positive test charge from one point to the other point. And what is potential? The potential is defined as the amount of work done on a unit positive test charge from infinity to this particular point. Am I clear or not? So this is the potential difference and the potential. Am I clear or not? So now moving ahead, here we go. Now if I am saying that I have a circuit positive, negative, and this one is also positive, this one is negative, and its resistance is, suppose its resistance is R. Okay, this is a particular circuit in which we have a battery, we have a plug key, okay, a closed plug key, an ammeter, a voltmeter, and a resistor, and its resistance is R. Now, what is actually a potential difference? We will be discussing it over here. Suppose I am saying that this battery has a potential difference of V volt, has a potential difference of V volt. Am I clear? It has a potential difference of V volt. It means it can perform a work. It can perform a work because if the electrons are to be flown, here is a resistor which will be resisting or opposing the flow of electrons. So we need an external source to make the flow of electron easier. And who will do it? So it will be done by the battery. Now, what is exactly a potential difference? If I am talking about the potential difference across these 2 points, suppose I am talking about the potential difference across these 2 points, that is A and B. So some electrons has to be flown from this particular point A to this particular point B. And for the flowing of these particular electrons or a charge, some amount of work has to be done by the battery. So we can say that the potential difference between these two particular points will be read by this voltmeter, and this voltmeter will be giving us the potential difference across this resistor. This voltmeter will be giving us the reading of potential difference across this resistor. Am I clear or not? Now, if I'm saying that in this particular section, there is no resistance. It means that the electrons or charge can easily flow. And if the electrons or the charges can easily flow, there is no need of work to be done. So, if I am talking on the empty wire that is without resistance, what does it mean? It means, so we have read that delta V was equal to W by Q. And as we know that an empty wire, that is without resistance, so there would be no work done, that is work done is equal to 0. Since delta V was equal to W by Q and W is 0, so 0 by Q is equal to again 0, therefore, sir, V final minus V initial is equal to 0. What does it mean? It means that V final is equal to V initial. Now, what does this mean, sir? It means if I am talking about these particular points, that is C and D, we can say that initial point was C, final point was D, because the electrons are being pushed to this particular direction because the current is flowing in this particular direction. So the electrons will be flowing in this particular direction. So we can say that the final potential will be equal to the initial potential. If the final potential is C, so we can say that Vc is equal to the initial potential, which was D, so Vc is equal to Vd. What does it mean? It means that there is no potential difference between 2 points if there is no resistance. Am I clear or not? If there is no resistance between 2 points, then there will be no work done, and if there will be no work done, it means there will be no potential difference generated. Am I clear or not? So if someone is asking that please tell me the potential difference that is delta V between EF. So what will be the potential difference between EF? Yes, it will be 0. Why is it so? Because we know that this is the empty wire, there is no resistance, so no work has to be done. If no work has to be done, it means that the delta V is equal to 0. If the potential difference is 0, what does it mean? It means that we can say that VE is equal to VF. Am I clear or not? Yes or no? Okay, that's great. So let us proceed further. So here we go. Now, we have studied about the potential, we have studied about the potential difference, we have studied about the resistor, we have studied about the resistance also. Now, talking about the potential difference or the potential. As the current was measured in ampere, So this particular potential difference is measured in volt. It is measured in volt. Now the work done is measured in joule. It is measured in joule, and the charge is measured in coulomb. It is measured in coulomb. So what we can say the volt is represented by V. So we can say from over here that V is equal to J by C. That is, volt is equal to joule per coulomb. So how we can define 1 volt? We can define 1 volt as 1 joule per 1 coulomb. Now what does it mean 1 volt is equal to 1 joule per 1 coulomb? It means if I have to define a potential difference of 1 volt, I have to define the potential difference of 1 volt, it means the difference between 2 points. So if I am saying that the amount of charge over here is 1 coulomb, because the amount of charge is 1 coulomb, and the amount of work done by the battery is 1 joule, then the potential difference will be 1 volt. Yes. So if I am defining the 1 volt as if the amount of charge is 1 coulomb, and this particular charge, the 1 coulomb of charge, is to be moved from one particular point to the other particular point, then there should be an amount of work done. And the amount of work done, if the amount of work done is 1 joule to move a 1 coulomb of charge from one particular point to the other particular point, then the potential difference between these 2 points will be called as 1 volt. Clear? If 1 coulomb of charge is flown or moved from one particular point to the other particular point, and 1 joule of work has to be done for the same, so the potential difference between these 2 points will be called as 1 volt. Clear? Okay, so moving ahead, here we go. So we have discussed about the potential difference, about the electric circuit, about the components of electric circuit, about the unit of the we can say the potential difference. Now we will be discussing about the factors on which resistance depends. Factors on which resistance depends. So there are few factors on which resistance depends. So resistance is represented by R. So firstly, we can say that resistance is directly proportional to L. What is L over here? That is length of conductor or length of material used. Okay, and this resistance is inversely proportional to area of cross section. Is inversely proportional to area of cross section of material. Area of cross section of material. So the resistance depends on the length of the material as well as the area of cross section of the material. And how does it depends? It depends directly proportional to the length and inversely proportional to area of cross section. Now combining both these equations, we can say that R will be proportional to L by A. And if we have to remove this proportionality sign, we have to introduce a proportionality constant over here. So we can say that R is equal to rho L by A. Now what is rho over here? The rho over here is called as the proportionality constant. The proportionality constant, which is resistivity over here, So R is equal to rho L by A. Am I clear or not? R is equal to rho L by A. Rho is the proportionality constant, which is resistivity over here. Now, what will be the unit of resistivity, sir? We don't know the unit of resistance also. So come, let us discuss about the unit of resistance first. After that, we'll be discussing of the unit of resistivity also. So talking about the unit of resistance, resistance SI unit of resistance is equal to ohm, OHM, and it is represented by this particular symbol. Am I clear or not? The SI unit of resistance is ohm and is particularly represented by this particular sign, that is omega. Okay. Now, if someone asks you what is the unit of resistivity, so can you determine the unit of resistivity? Yes, we can. How? Let us see. If R is equal to rho L by A, since R was is equal to rho L by A, therefore we can say that rho is equal to R A by L. The R is measured in ohm, the area is measured in meter square, the length is measured in meter. So yes, SI unit of rho is equal to ohm meter. Am I clear or not? The SI unit of resistivity is ohm meter. Now what does this resistivity means? What is this resistivity? We have already discussed about resistivity, that it is the proportionality constant. It means the resistivity of any of the material will be always constant. The resistivity of a material will always be constant. So does resistance depends on resistivity also? Yes sir, we can say, because resistivity is the constant for any of the material. Now, on what factor resistance was depending? Resistance was depending on length, on area of cross section, and there are two more factors on which resistance depends. And what are those? Come, let us see. The first one was on length, the second one was on area, and now coming on the third one. Resistance also directly depends on temperature. Temperature. Am I clear or not? Resistance directly depends on temperature. So if we are increasing the temperature, the resistance of the conductor will be increased. If we increase the temperature of the conductor, its resistance will also increase. Okay? It is basically resistance of conductor. Resistance of conductor. For semiconductor, this particular rule will not be followed. We will be studying it in our higher classes. For conductor only, if the temperature is increased, the resistance also increases. And what was the other factor? The resistance depends on nature of material. On nature of material. Nature of material. So four factors: the length, the cross-sectional area, the nature of material, and the temperature. Am I clear or not? Come on, note it down. So what we have discussed, factors on which resistance depend. What was resistance? Resistance is the ability of a conductor to resist the flow of the current. What was its unit? Its unit was, SI unit was ohm. The resistance of a conductor depends on length of its material, depend on its area of material, directly proportional to length, inversely proportional to area. So we have derived a relation, that is R is equal to rho L by A, where rho is defined as the proportionality constant, which is resistivity over here. So from here we have derived the unit of rho, that is resistivity also, which is ohm meter. Resistance also depends on temperature, directly proportional if we are talking about the conductors. Okay, and the resistance also depends on nature of material. Now moving ahead, and here we go. So our next topic is the Ohm's law. The Ohm's law. What does Ohm's law states? See, the Ohm's law states that the potential difference across any two points is always directly proportional to current flowing. Am I clear or not? The potential difference across any 2 points is directly proportional to the current flowing across these terminals. Now, the Ohm stated that it will only hold if temperature is constant. If temperature is constant. Okay, so this is the condition for it. Now, if we want to remove the proportionality sign, we have to introduce a proportionality constant. So here we can say that delta V is equal to Ri, where R is the proportionality constant, which is equal to resistance, Am I clear? So if the temperature is constant, the resistance won't be changing. Am I clear? Because it was depending on the temperature. So here if temperature is constant, resistance will also be constant if its length and area is not varied. Am I clear or not? So yes, we can say from here that V is equal to IR. The potential difference is equal to the product of current and the resistance. So how a potential difference can be directly proportional to the current flowing? So in actual, if we see, it was like the current was inversely proportional. In actual, we can say that the current was directly proportional to the potential difference applied across two terminals. If I am saying that the potential difference is applied across two terminals, then only current will be flowing. It means current should be directly proportional to potential difference. It means if the current is depending on potential difference, so I should be directly proportional to delta V, not delta V should be directly proportional to I. But yes, we can say if we are in the class 10th standard, we can say that yes, potential difference is directly proportional to current. So yes, V is equal to IR. But in actual, what happens that I is directly proportional to delta V, and if we have to remove this particular sign, we will be removing it by placing it G over here. G over here. Am I clear or not? Now what is G over here? Now what is G? Sorry. G should be on the top because we are removing. So here we will be I is equal to G delta V. Now from here we can say that delta V, therefore delta V is equal to I by G. Now here delta V is equal to I by G, here delta V is equal to IR. So comparing these two, the left hand side is equal. So comparing right hand side, Ri is equal to I by G. So what does it mean? It means R is equal to 1 by G. So yes, R is equal to 1 by G because here this proportionality constant is called as conductivity. It's called as, sorry, not conductivity, it's conductance. Am I clear or not? In this particular equation, the R was called as resistance, but in this particular equation, the G is called as conductance. So conductance is just the reverse of resistance because its function is also just the opposite of the resistance. So we can say that G should be reciprocal of resistance, and hence we are getting the relation between R and G, that R is inversely proportional to G, or we can say that R is reciprocal of G. Am I clear or not? So for you guys, for 10th standard, we will be noting this particular thing, not this one. But in actual, it is like this. Am I clear or not? So this is the particularly Ohm's law, that V is equal to IR. Now, the temperature should be constant, and also the temperature should be low. The temperature should not be that much high. It should be low only. Am I clear or not? Chalo. So moving ahead, here we go. Now, if I am saying that V is equal to IR, it means the Ohm's law stated that V is directly proportional to I. And if V is directly proportional to I, it means that we can say that its graph will be straight line. Its graph will be straight line. And if its graph will be straight line, here we can see that suppose V is mentioned over here, I is mentioned over here. So yes, its graph will be going like this because it is a linear graph. V is directly proportional to I. It means if I am increasing current by factor 2, potential difference will also be increased by factor 2 because it is directly proportional. Now, if I am talking about the resistance, The resistance can be defined as V by I. The resistance can be defined as V by I. Now, if the resistance is defined as V by I, we can just find out the relation between the resistances of different graphs. How is it so? Let us find out. Suppose I am saying that here are two graphs. One particular this graph, one particular this graph, and also we have one more graph, that is this one. Okay. So if the question is asking that whose resistance is greater, the R1, the R2, the R3, whose resistance is greater? Sir, R is equal to V by I. So if we take the current to be constant, if I am saying that I is equal to constant, if it's my assumption, if I is equal to constant, therefore R is directly proportional to V. R is directly proportional to V. How we can keep I constant? Sir, I am drawing a line, and for this particular line, I is constant. Am I clear or not? I is constant. Yes, sir. The potential difference is increasing, but the current is constant. It means the current is constant. And if the current is constant, we know that if this is V3, this is V2, this is V1. So we know that V3 is greater than V2 is greater than V1. And since R is directly proportional to V, therefore we can say that R3 is greater than R2 is greater than R1. So in this way, we can find out the relation between the different graphs. We can find out the relation between the resistances of the different graphs. Am I clear or not? Yes or no? Yes or no? So whose, sorry, it should be like this. I have mentioned a wrong naming over here. So if it is V3, so it should be R3, it should be R2, and if it is V1, it should be R1. Am I clear or not? So R3 is greater than R2 is greater than R1. Yes? Okay. So if I am saying that the graph is not given as VI graph, but we have been provided as IV graph, what will be in that particular case? Let us see. If it is given IV graph, if it is given as IV graph, again we have three particular graphs. Again it is R1, it is R2, it is R3. Since we know that V is equal to IR, we need to find out the relation between the R. Therefore, R is equal to V by I. Now, if I say that again, sir, again I need to take the I is equal to constant. Suppose I am taking again if I is equal to constant. If I is equal to constant, therefore R is directly proportional to V. Okay. So how we will be drawing I as constant? So in this particular manner. In this particular manner, we can say that I is constant, and if I is constant, this one will be V1, this one will be V2, and this one will be V3. We know that V is increasing over this side, so V1 is greater than V2 is greater than V3, and since R is directly proportional to V, therefore we can say that R1 is greater than R2 is greater than R3. So in this particular case, R1 will be greater than R2 and R2 will be greater than R3. But what was happening in the previous case? It was just reversed. Now here we can say that R3 was greater than R2 and R2 was greater than R1. But what happened in this case? R1 is greater than R2 and R2 is greater than R3. Am I clear or not? So in these particular manner, we can find out the relation between the resistances of the different graphs. Yes? Okay. So what we have discussed till now, let us have a look. Electric circuit, closed and continuous path of flow of current, cell, battery, resistor, variable resistor, plug key, bulb, crossing over, wire joint, ammeter, voltmeter used for measuring current, voltmeter used for measuring potential difference across the 2 points, resistance means ability of a material to resist the flow of the electron. Potential difference was defined as the amount of work done on moving a unit positive test charge from one particular point to the other particular point. How we are defining the potential term? So the potential of a particular point is defined as the amount of work done on moving a unit positive test charge from infinity to that particular point. Am I clear or not? How we can define as 1 volt? 1 volt is defined if 1 joule of work is done to move 1 coulomb of charge from one point to the other point, then the potential difference between these 2 points is called as 1 volt. Moving towards the next slide, here we go. Now, whenever an empty wire is taken, if empty wire is taken, that is there is no resistance. If there is no resistance, therefore there will be no work done. If there is no work done, we can say that the potential difference across this particular section will be 0. If potential difference is 0, it means that the potential across both the terminal will be same. That is VC is equal to VD, V is equal to VF. Am I clear or not? So moving ahead, there we go. Factors on which resistance was depending: directly proportional to length, inversely proportional to area. It depends on nature of material. It also depends on temperature, directly proportional to temperature. So R was is equal to rho L by A, where rho was the proportionality constant and which was equal to resistivity. The SI unit of resistance was ohm, and moving ahead, the SI unit of resistivity was ohm meter. Am I clear or not? Moving ahead, what was Ohm's law? Ohm's law stated that the potential difference across the two terminals is directly proportional to the current flowing through these terminals. The potential difference across the two terminals is directly proportional to the current flowing through these terminals, and for the constant temperature, and also the temperature should be low, not that high. So V is equal to Ri, where V is the potential difference, I is the current, and R is the resistance of the material used. And what was this? No need to summarize it. The resistance is the reciprocal of the conductance. So you have to note down that G is the conductance, and yes, the conductance is directly is the reverse of the resistance. Conductance is the reverse of the resistance. So what will be its unit? Its unit will be 1 by ohm. Am I clear or not? Its unit will be 1 by ohm. The SI unit of G will be 1 by ohm, or you can say ohm inverse, or you can say maho. ठीक है, ulta, ohm का ulta, that is maho. Moving ahead, here we go. So V was directly proportional to I. So from this particular equation, we can compare the graphs of different resistances. Okay. So all this for a day. Now in the next class, we will be learning about the resistances combination, how they are connected in series, how they are connected in parallel, and after that we'll be discussing about the power and the we can say the heat energy dissipated. Okay. So that's all for the day. Thank you so much, class.